Okay, this video is going to cover the use or go through the tutorial, Cadence 1 tutorial at CMOS EDU. So let's take a look on, click on the videos, then written video tutorials here, and then tutorial 1, and then when we're done recording, I'm gonna post it to this link right here and we'll go through each one. So we'll go through this, and the goal is to make sure we can use the tools and things are straightforward and we understand what's going on, not just that when I say we understand what's going on, we understand what the tools are doing, not just how to operate the tool. So we're going to set the Cadence up to use on C5 process, which is, at the time I'm doing this, what Moses provides to universities for tiny chips for free fabrication through university classes. So to begin, we want to download the NCSU CDK, so let's click on that. And while that's coming up, we'll see we want to download right here. Now when you do the download, it's important that you download from the same machine or IP address as you use to check, and you use your email on the same machine and IP address to get the download. So what we have to do is we have to register here, and so let's put my name, so let's keep it simple, Jake Baker, Boise, and let's put CMOS EDU, and then my email address, submit form, and then let's go ahead and sign into my email account. And oops. And we hopefully have an email from NCSU. We'll go download, and it says right there it only works from the same machine or IP address that you requested it from. So let's download this file right here, NCSU. Let me hit Control, make this a little easier to see. NCSU Cadence Design Kit 1.6 tar. And let's save to disk. And I think I have it set up to save to my desktop, so let's hit OK. And it's downloading. And while it's doing that, let's go back to the video and the written tutorials, tutorial 1. And we've just downloaded the CDK. So now the next step is to extract the properties. Oh, it's still working. And holy cow, how big is that file? Well, while that's doing what it's doing, we need to extract the file. Then we need to move that extracted contents into the home folder. And my home folder is Home Faculty J Baker. Let's see if it's done. It looks like it's done. So let's right click, extract here. And then let's move this up. Let's take our home, open a directory window here, and it's in the home directory or home folder. Let's drop it down in, move here. So if we go take a look now, there's the setups, and you can see in the library here there's lots of different ones. We're going to use this one right here. Let's go back to the home directory and see what the next step is. And let's see, we moved it there. Okay, so our next step is to open our bash file and make sure we can view hidden files, and then copy this stuff. So I'll grab that and do a Control C. Then go over to the bash file, open it, paste that stuff in here. Let me make it look a little prettier. Some of these have to do with how net listing is, how net listing is done. So if you 3 transistor versus 4 transistor symbols, how they're handled. Okay, so I'm going to save the bash RC. And let me just make sure I can view hidden files. I know I can, but just to show you, show hidden files. Okay. And now I need to resource the bash. And let's close this one. And you resource the bash by opening a terminal window and typing that. So let's right click here, go to console, and I'm in the home directory, home or dot space dot bash rc. It's resourced. Whoops, let's see what's next. Okay, next we need to make a working directory called CMOS edu and copy everything in here into that working directory. So I selected that and did Control C. So let's go right click in here and create new folder, CMOS edu. Okay, then let me put the stuff in here, Control V, and let's change the view. Grab everything here, do a Control C, we copy it, don't move it, and then it said to put it into CMOS edu, so we'll do that, Control V. Oh yeah, we're having fun now. And then the working directory, of course we won't have to do this every time, just this first tutorial, because once it's set up we're good to go. We need to rename CDS init, SIMRC, and CDS envi to add a period in front of them, so let's do that. CDS init, right click, rename, or F2, which I'll use from this point on, period. CDS SIMRC was one of them. Whoops, I said I'd use F2 and I didn't. So I'll use F2, period. CDNS init, SIMRC, what was the last one? CDS environment. We'll right click and period. Okay. Now what? In CMOS edu, open the CDS Live and add the definitions or pointing to the Cadence built-in libraries, and you need to make sure these paths are consistent with your setups. They may be in a different local or user directory, so select those and do a Control C. CDS Lib, come down here, paste these, and let's close that. Save. Alright, let's see what's next. Finally, in the NCSU CDK Lib, let's just cheat and do this. We need to delete these rule files. While we're at it, let's save this here. What just happened? Click on that. And let's right click on it, save link as to desktop, save. Oh, it's already there. Okay, so let's go back and put down that path, go in there, and then we need to find the rule files and delete them. See, they're locked and they point to somebody else's directory, so that's a little bug in this version that'll be fixed in the final release. This is the beta release, so let's hit delete. Let's go to the desktop. Oh, I downloaded it. It's not showing up in my window for some reason. So let's delete that one. Let's right click on that and extract here. Let's go ahead and delete the zip file. Then let's do a Control-C on there. Go back to NCSU CDS. Here, let's just cheat it. Yeah, let's go in right there and right click. Hit paste. There they are. Let's just make sure. Well, you can see they're not locked already. So let's minimize that. I think we're done. Okay. We're now ready to start Cadence. So what I'm going to do from this point on is I've got two monitors, and I'm going to open this, or I've already opened it in another monitor, so I'm going to follow along and do the tutorial after we start Cadence. So the first thing I'm going to do is I'm going to CD into change directory into CMOS EDU, and then I'm going to start Cadence Virtuoso and I'll follow what we're doing in the other tutorial. So why don't I go ahead and close this for now. Open that tutorial up, CD into CM, and if you press tab it completes it for you. Then Virtuoso ampersand runs the process in the background, doesn't lock the terminal. So we get it going here, and I'll pull up the tutorial and follow. I'll go along with what the tutorial is saying as close as I can. And so looks like the first thing in the tutorial, we adjusted the window sizes a little bit, so let me do that. This window here is the CIW, or Command Interpreter window. This window up here is the Library Manager. First step is we need to create a new library that is associated with the C5 process, the AMI06. So I'm going to go to File, New, Library. And then thinking. Oh, it's taking a little bit of time there. Huh. Must have a lot of users on the machine right now. I've never seen it take this long. Oh, it came up. I just was behind the window, and I gotta move this over. It was sitting there. So let's call this tutorial _1, and let's put the path. We don't need to add. All we need to do is attach tech library here and say OK. And there's the tutorial library. Now before I go any further, let's go back and look at the CMOS EDU. Let's close all this up nice and neat. Go back in here and look at our CDS lib. It added this line at the bottom. Oops, I didn't have a carriage. Good thing I didn't have a carriage return in there. Good thing we're looking at this. It added the line at the bottom. If I were to download and run some of the simulations at CMOS EDU, like the Chapter 1 simulations, I'd need to add this definition into the CDS lib, just like it says in the tutorial. So it points to it knows that there's a library in there, and the library manager knows where to find it. So, for example, in the well, we can pull one up real quick. If I were to download Chapter 1, we're using version 6.1, this zip, I could unzip these into the CMOS EDU directory, and then all I need to do is add this to the CDS lib. Okay. All right, and then we're good to use those simulations from the book. Okay, so let's hit save, close, minimize this. And then what we're going to do first is we're going to make a resistive divider. And so let's go select the tutorial, go up here to File, New, Cell View, and it keeps putting them behind. So let's call this rdiv and schematic. Yep, it automatically did that. And so it tells us our path. And OK. And there it comes up. There's where we're going to do our drawings. And so let's resize it. I'm doing this little teeny screen, so the video's not too big. And we want to add an instance, which we can do here. Or we could come up here and go to create instance, or what I'll do most of the time is just press I. Okay, so let me stretch this out a little bit. So I'm going to select, I'm in the NCSU analog parts, that's where I want to be. I'm going to select RLC and then resistor. I'm going to change the value of the resistor to 10K, hide it, minimize this, and then I'm going to right click to drop one resistor down, and then right click again to drop another resistor down. Now I'm done putting resistors. I'm going to hit escape, and then I'm going to hit F for fit, or let's see, where is it? Fit, right here, F. So it fits the screen. Now, oops. Now the next thing I'm going to add, oh yeah, before we go on, I can then change the value of the resistor by selecting it and then either hitting Q or Edit, Properties, Objects, Properties. Okay, so we can hit Q and then change the value or put temperature coefficients or whatever. So, okay. Next, I'm going to add a ground symbol. So I can go back here, compress this time. Now I could put ground in here, just type it in manually, but I'm going to go ahead and instead hit the supply nets, select ground, hide, and drop it. Now, when I'm dropping components, I can go to view and zoom out in by 2 or zoom in by 2 or zoom out by 2, Shift Z. So here I'm going to press Shift Z or capital Z and drop the ground in. Then I hit escape. Next I'm going to instantiate, press I. And whoops, I want voltage sources and VDC and instantiate. Oops, try it again. Voltage sources, VDC, and I want a DC voltage of 1, hide. Okay, so let's drop that in, and that looks good. I'm going to hit fit. Now I'm going to hit escape. Okay, so last but not least, I need to wire the circuit together, which I can do by pressing W, or I can hit the icon right here. Let's use W for wire. We're almost ready to simulate. I think the next thing in the tutorial is to label the wires. So we can press L, or we can hit this thing here and hit in, hide, and then here, out, hide, and let's put it right there. That's good. Hit escaped, leave that mode, click in there somewhere. Let's see what. Let's do a check and save. So we can hit check and save like that, or we can go to File, check and save, or we can press F8. Let's just hit check and save right here. Okay, there's no errors. All right, we're ready to simulate. We need to start the analog design environment, or launch the analog design environment, ADE. So we click on that. We go through, and the first thing we need to do is set the analysis. So we'll choose, and we'll simulate for 1 second, a .tran, and we got to make sure we enable it. Okay, now it pops up here. Next thing we need to do is we need to set which signals we want to save. And so let's go to Outputs, To Be Saved, select on Schematic, and let's select this one and this one. And you can see down here they show up. But I don't want to have to do this every time I start the simulation, so I'm going to go to Session, Save State, Cell View, so it'll save the state in the cell view, and it's called Spectre_Save1, and I hit OK. So if I go back to the Library Manager now and click on that cell, I see that we have two views. We have a schematic view and we have a Spectre State 1 view. Okay, so I'm ready to simulate. I press the Netlist and Run, or the green button here, or this right here, Netlist and Run. Let's just hit the green button. And it starts running. And let's see. Did I plot that? Oh, somehow I didn't have plot saved here, so let's save the state again. Okay. Overwrite the save state, yes. Let's try it again, but this time have it plot. We could have just selected the two and hit the plot down here too. But let's let it run. All right, there we go. Yay, it worked. All right, so we did our quick little simulation. Now, but what I want to do is I want to make this, let's close the ADE. I would rather this simulation here, or I'd rather make this cell more useful for an integrated circuit. And that means we need to make the cell have pins that you can use to connect up in the integrated circuit, not a voltage source. We'll put the voltage source in for the simulation, but we won't do it in the cell itself because we can't lay out a voltage source. Okay, so let's go ahead and delete the voltage source. So I select something and I hit delete. I'm in the delete mode now. That once I've done that, it remembers and it stays in that mode until I get this schematic right here. Okay, so now I'm going to add pins. Now I can go add a pin by clicking here, or I can go create a pin by clicking here, or I can hit P. So let's just select it here. Let's call it in, and it's an input. So I can put it here. Then I press P to add another one. Let's call it out, and it's an output. Let's drop it here. Then I press W for wire. Come in. There it is, fit. Now notice I called these pins in and out to match the wire names, but that's not necessarily, they don't have to necessarily match. They can be different. So I hit check and save. No errors. And you know what? I'm not able to see the CIW quite as good as I like, so let's hit fit. All right. So now we're ready to create a, whoops, let's hit escape. Let's create a symbol view. Let's go look at the Library Manager. Again, we just have our schematic and Spectre State 1. So let's go up here to Create, Cell View, From Cell View, and we want a symbol. So we hit OK. Left pins, fine. Right pins, fine. OK. So there it creates a symbol for us, which is a little more fancy than what I like. So I'll go back to the Library Manager, and now there's 3 cell views for this RDiv cell. Schematic, the Spectre State, and the symbol. So I'm going to, following what the tutorial says to do, I'm going to delete everything in here. Let's hit delete. Delete. Whoops. Let's do undo. Press U a few times. I didn't want to delete the in and the out terms. And let's pick some of these other stuff. And then hit escape. Let's move this up so I can see the CIW again. And then let's select, if I'm still in that mode, and now press move or edit, move M. So let's move that right here. And M again. Whoops. Not N, M. Okay, So we hit fit, click in there, press escape, get out of that move. So now I'm going to add a shape. So I'm going to create shape line, and I'm going to draw a resistor. Oh yeah. And let's go back here. Whoops. Okay, let's go create shape line again and come down. Now I'm going to press Shift Z so I can zoom out a few times and just draw another resistor here. Shift Z, and let's hit fit. Shift Z a few times. Really hard with this teeny little resolution. Reduce the size of the video. Boom. Oops. Okay, so we're done. So we'll hit fit. Now, what we want to do, we want to check and save. Make sure everything's okay. It is, so let's close both the symbol view and the schematic view and go back to the library manager. And let's copy this cell because I want to minimize the amount of clicking I have to do, and I already have the save state here. So let's do a right click on there, copy, and let's make a special cell called sim_rdev. Okay. The files are being copied. Now I no longer need in RDev here this spectre state because I'm not going to simulate this cell. I'm going to simulate it once I put it in this one. So I'm going to delete this state here. Delete. Okay. Are you sure? Yes, I'm sure. Just keeping the house clean there. Open this up, and I don't have a symbol now. I'm going to place my schematic in there. So let's hit delete on that, or right click on that, delete. Okay, yes. Okay, so now I'm going to open the schematic view of my simulation. And I'm going to delete everything here. I don't need it anymore. Delete. Then I'm going to instantiate or press I. Let's press I. Let's use the menu. And then I'm going to browse my component browser, and I'm going to go to Tutorial 1. Select my RDev. Let's minimize this. And let's zoom out with Shift Z a few times and just drop that schematic in there. And then let's hook everything up. So we can go press I again, component browser, go back over to the NCSU analog parts, get the voltage sources, DC, put it at 1, drop it in there, go back up, we're already up, go to supply nets, ground, drop that in there, hit escape, press W to wire everything together. I'm going to throw a wire on the output here. Then I press L or this, in, and L or out. Now I'm ready to check and save my schematic. And it says there's 2 warnings. So I go up to check, find marker, and it could say zoom to marker, and then it zooms into where the marker is. But I can see this is a pretty simple schematic. Press F, what the error is, that the wire's floating. So I'm just going to hit ignore twice to ignore both of those. Apply, hit the X to close the window, fit, check and save. Now there are no errors, or warnings rather. Okay, before we go on, Or actually, let's simulate this first. So let's go launch the analog design environment, session, load state, because remember we copied the cell over, cell view. Let's move this up so we can see OK. And it remembers, oh, this time it remembered in and out. In the tutorial when I wrote it, it didn't remember. All right, so now I can hit netlist and run. And we should get the exact same results. We do. Let's close her down. Now, before we go too much further, let's select this cell, because it's a cell. That's just what we drew the icon to look like, and go to Edit, Hierarchy, Descend Edit, and then we'll see here return is B. So Shift X is capital X is Descend Edit, and let's open it in the current tab. Say OK. And then if we press B, we go back up in the hierarchy. So Shift X, descend, OK. B goes back. Shift B goes all the way to the top. So check and save. We're done. OK, so now we want to make a layout. We want to make a layout of the RDev cell. So let's just open the schematic to remind ourselves what was actually in there. So we have a resistor 10K and 2 pins, and that's about it. So let's go. We need to now select RDev, go up to File, New, Cell View. It keeps putting them behind there. Layout. And say OK. Now let's turn off at startup. OK to turn off. What's new message? Yes. OK, so let me pull this over a little ways. Pull this up, move it up. Let's move the CIW over a little too. LSW is the layer selection window. AV would be all visible. NV would be none visible except the one that's selected. AS is all selected. All are available to select. No select means that you only get the one that's selected. None selected, I believe it's just the one you have highlighted, but it looks like that's not the case. So all selected, all visible. That's useful if you have a complicated layout and you want to move something and you don't want your mouse to select something. One of the layers, some of the layers, you only want it to select one specific layer. Okay, so let's do a few things here. To begin with, go to Options, Display, and we want to show pin names in the layout. We also want to be able to move diagonally. Some people might want to even go any angle, but I'll just leave it at diagonal. If not, then when you move something around, it's going to go in an orthogonal direction. We'll also ultimately want to set the display level to a higher number, say 10, so when we drop a cell down in, it's not drawn as an outline. We can see its contents down a certain number of levels. So we hit OK. Now we're ready to draw a layout. Now, as mentioned in the tutorial, the layout size, or the sheet resistance of N-well is 800 ohms. Now I'm not going to go through what that means. This tutorial assumes that you know what sheet resistance is, or you know that to make a connection to the N-well you go through metal 1 to a contact to N+. I'm not going to cover that stuff. What I'm going to do instead, we're going to use N-well, and as you see in the tutorial, the size we're going to use is 4.5 microns wide and 56 microns long. And so let's close this cell for now and go up to the library manager, and we need to make a resistor. It's because in this cell here we had a resistor from the symbol, but we don't have layouts. We don't have a layout that we can place in the corresponding layout here. Let's see, view, refresh. Okay, so what I'm going to do, I thought I made a layout cell here. Anyway, let's go back, and maybe it didn't save it because there was nothing in it. Let's go File, New, Cell View, layout, and let's call it, what did I call it in there? RN well 10K. Okay. Let's resize it. Fit. Then let's just let's select the N-well layer. And go to Create, Shape, Rectangle, or R. And now you click, drag, and click again. Don't click and hold. And you get a box. Now I'm still in the rectangle mode, so if I draw another box like that, it will continue. I can draw another box. Let's hit undo, then escape to get out of that mode. Now I'm going to select this object and I'm going to hit Q, or edit, properties, and I'm going to set the left, it says 56, so I'm going to set the left to -28, the right to 28, the left to -28, the bottom to 2.25, and the top to 2.25. Hit OK, place fit. Okay, so there's our resistor, which has a number of squares that should correspond to a 10K resistor. Before I go any further, I'm going to design rule check, which means I'm going to go over to Verify, DRC, OK. And I go through here and it says, hey, you have 4 errors. Okay, so what are the errors? I know I made the N-well wide enough. So we can find out what the errors are. If you look, the markers are here. It's easy to see. But if we go up to Verify, Markers, Find Marker, and you can zoom to the markers, and let's do that. Apply. It says, hey, it zooms in, shows me here's a marker, and then it says, okay, the error is that the edge is not on grid. Okay, so let's go hit fit again. And if you look at the discussion, well, let's look. We need to find out what our grid is, and we can do that by pressing E, Display Editor. We see our grid's 0.15, and we can see what the grid spacing is. Well, you know what? Let's zoom in. Yeah, let's zoom in on that corner where that marker is. Let's go to Tools just to see. Let's go to Create Ruler, or K, and drive it over here. Yeah, let's click. And you can see that each one of these marks should be 1. And to get rid of the tool, so that corresponds to, I'm going to press E. That corresponds to the spacing of 1, but the snapping is 0.15. Of course, lambda is 0.3. So that's a half lambda grid. Okay, so I can get rid of that ruler by capital K. So as discussed in the tutorial, what I need to do is I need to adjust the size of the N-well so that it falls on grid. And I can do that by putting in here 28.05 and minus 20, or plus 28.05 and minus 28.05 to get it on grid. Verify, DRC, OK. Notice no errors found. Okay. Next, I need to add connections to the N-well at the 2 ends. And so what I'm going to do there is I'm going to go up, press I, or that instantiate there, hit Browse, go back to the NCSU AMI parts, and what's used to connect to N-well is the N tap. And that's seen right here. And I'm going to put 2 rows just to make it a little bit wider, although we could use 1 row. I'm going to drop it in here, and notice it keeps wanting to, has an affinity towards the N-well, and I don't want that. So let me hit Shift Z and zoom out and just drop them on the ends here. I don't like it that it keeps wanting to hit the N-well. It's snapping there. And the problem with, and what's causing that is gravity is on. So if I go up to Options, Editor, and I look, gravity is on, and that can be useful in some situations. It's not useful here. It's annoying. And so I'm going to turn gravity off so I can move those. And then I want to see what's inside. And this is what we talked about earlier, where if we don't have any depth in our view, we only see an outline. So I'll go back to Options, Display E, and I'll set the stop level at 10. So now I can see what's inside. So I can go down now and hit Zoom, and then select this, and M for move, and move it. Now I can move it without the gravity affecting things. Fit, zoom, move. Okay, whoops. Let me zoom in a little bit more. Oh, something's not right. Let me go back and just edit any angle. Press M. Okay, fit. Let's DRC it real quick. Okay, no errors. Notice how it's nice having that CIW visible. Okay, so now we need to export pins. And so what I'm going to do, I'm going to create a pin shape. So I can go here, create pin, or I can go create pin here. And I'm going to call the terminal, one terminal of the resistor L for left. And then I'm going to make sure I hit display pin name, hide. Zoom in here. And I'm going to just put it over, oops, I made a mistake. One other thing, escape here. I need to know what layer the pin's going to be on, so I need to select metal 1 before I do a pin. So pin, create one, display pin name, hide. So I'm going to just put that pin over the entire piece of metal there. And then there's my shape. I'm just going to drop it right in the middle. Notice if after I drop it the L doesn't show, I can go press E and verify pin names is highlighted, and then when I I generate a pin here, press P, I need to make sure display pin name is highlighted here. So this could be right. Okay, hide. And I'm in that mode, so I got to zoom in. I'm still on metal 1. Select here. Boom. Hit fit. Everything should be fine. Our total resistor is done, but we don't know it's a resistor. So what we need to do is tell Cadence that it's a resistor. So I hit resistor ID, press R for rectangle, and then I'm going to draw a box. Oops, zoom in first. Then I'm going to draw a box, press R again, hit fit, zoom in. Over that layer of N-well that says, hey, that's my resistor right there. So now I've said it's a resistor. Before I go any further, I'm going to extract the resistance or the electrical parasitics from those layers. So let's go up here. Let's save first. Let's go to verify and then extract. Hit OK. Okay, 0 errors. And then now I see there's in the N-well 10K, there's an extracted view. Let's go ahead and look at that. And there's the layout, and then it puts the schematic equivalent on the layout. So let's zoom in. And it says, hey, it's 10.21K. Should I worry about the 0.21K? No, because N-well sheet resistance varies, and that's why I used ratioed components when I'm doing layout. I can't get a precise value because the process manufacturing varies with each process run. Okay, so let's close this extracted view. Let's close the layout of the resistor. Now we're ready to draw the layout of the RDEV cell. We want to draw the layout here. So let's go open it again, just so we remember. We need 2 resistors. I'm not going to draw them like this. I'm going to draw them parallel just to take less space. And I'm going to create a layout view here. I thought I had one, but apparently since there was nothing in it, so that's fine. RDev, cell view, new, layout, OK. There it is. Now I'm going to instantiate, press I. Whoops, so I get access to all this stuff. Go to my component browser, select the tutorial one, select RDev, which is the layout of the resistor. Come in here. Thought I pressed I. Hide. Oh, whoops. Don't know why it's not putting in the right value, but we'll fix that. Tutorial _1 and R_div. Hide. Cannot create. Oh. Close. Let's see. There's the layout. Why isn't that showing up? Maybe we need to close the component browser. Let's close that so it rereads the contents. So virtual, yep, that's right. Library manager. Yep, virtual. Let's close that. There's our layout. Let's press instantiate. Let's browse. Tutorial 1. I guess we needed to oh, that component browser was for the schematic, duh. Okay, layout. There we go. So let's drop that down. Fit, and let's drop one right below it. Let's not make an error yet. We'll have error soon enough. Boom. And of course, if things aren't being shown, let's zoom in and make sure I lined everything up. Zoom. Looks good. Okay, let's DRC it. It may be too close, so let's verify DRC. OK. 2 errors found. Yep, they're too close, so let's select that. Press M. Move it down. Let's press E and go back into the diagonal so I don't have this. Let me just query that, and let's see the X, and let's put it at -10. Okay, apply. Okay, let's see where this one's located. Whoops. Q 00, good enough. Let's DRC again. Okay. Whoops, not on grid. Didn't I have that on grid? Oh, that's right. Let's try 9, so that's divisible by 0.15. Okay. And then verify, DRC, OK. Oh, now it's back to being too close. Let's see. Let's go. Let's see. What's divisible by 0.15? How about 12? I think that is. Verify, DRC, OK. All right, fit, click somewhere there, escape. All right, so we have our layout there. We're ready to wire it together, so let's go back to the Metal 1 layer. I'm not used to such a small screen. Metal 1, press R. Let's hit escape. Zoom. R. Fit. Zoom. R. Zoom in one more time. R. Fit. Zoom. Fit. zoom, R again. Now we need to, just like in the schematic view, we need to add pins in, out. We need to put ground in there. So let's do that. Let's go back and go to pin on metal 1. So press P. Oops, wrong one. Create pin. And that was called in. Now display pin name. Now notice I'm going to make a couple of mistakes. IO type is input output, but in our schematic we selected input. Okay, so let's zoom in here and put our pin down. And then we can put that there. That white tells us lettering what where to connect things up. Create pin. Let's call this GND. That's going to also be a mistake because when you use ground and VDD in their global symbols, you always put an exclamation point behind it. So let's do that. And go there. And then zoom in over here. Whoops. Create pin. Out. Again, same mistake. We don't have the IO type right. So let's just do, whoops. I made that off a little bit. Let's just start over. Out, hide, zoom. Okay, fit. Yeah, let's zoom in. Okay, I think that's pretty close to what I had in the tutorial. Oh, I skipped one thing. So let's do a check and save. Save. Let's verify DRC. Okie dokie. No errors. Let's go press E for options and shut off or put this back at 0 just to see. You can see there's the outlines and how I drew the boxes. So you can go back to E and put it back on 10. Okay, fit. Now save. We can extract now. We just DRC'd. We can extract the layout. So let's do a verify, extract. Okay. Says it was extracted. Okay, we can go back to the library manager. And let's see, we were in this one, so we can double click there. Pulls it up. You can see the extracted connections and how things are there. Let's close that. We need to always do an extraction before we do an LVS. We're going to do our LVS right now. Verify layout versus schematic. Why doesn't, I don't want to type all that in. Why is it? Let's see, verify LVS. Let's see if I can browse quickly to it. Tutorial 1, RDev, schematic. We'll close and let's browse over here. Tutorial 1, RDev. Extracted is what you compare it to. You don't compare it to the layout. You can compare it to the extracted. Close. OK. Run. It's running. It says the LVS has succeeded. That does not mean that it's LVS, the layout, and the schematic are the same. I can look at the output, and I see right here the netlist failed to match. And I can zoom in, down, go down, and look for the errors. And it says, hey, ground is not present in the layout, ground bang or ground exclamation, which we knew, and then terminal ends type in schematic as input, and in the layout input output. So I got to fix those. I can also go over, open up the extracted view, and then go to error display, and go to find the first error. And got no space here. Next. Wait, what just happened there? First. Error display. First. Oh, okay, we're just in the wrong views. I need to open up the extracted view. Okay, so close. We'll just use the text for now. Okay, close this. Go fix those errors. So first error I'm going to fix. Go down. Let's see what we have open. Cancel. Let's cancel this one. Go zoom in. Why aren't I able to get the let's hit escape a few times. Okay, I was in some funny mode. Alright, so query that. Connectivity, we want it to be output. Okay. Query that. We want that to be ground bang. Okay. Query this one, and we want that to be, whoops, connectivity input. Okay, so before we do the LVS again, what we need to do is extract the layout view. So let's do that. So let's save it first. Create or verify, extract, OK. They're extracted. Now we need to verify LVS. The selected LVS does not match the tutorial RDev. What the heck? Verify LVS. Okay. Run. Succeeded. Output. The netlist match. So our layout and schematic match. Okay, well that's enough for this first tutorial. We covered quite a few things. So let's go and I'll post this. It's already posted. Exit. Okay to exit Virtuoso. Yes. And we'll post it and it'll be available for you to watch.